Known for its huge passenger capacity, amazing velocity, and high safety standards, China's high-speed railway service is weaving a network all over the country. And as it reshapes the ways people live, work, and travel, the techniques it has developed are also contributing to global railroad development. As of the end of June 2022, the total operating mileage of China's high-speed rail system surpassed 40,000 kilometers, firmly staking its claim to the first place in the world. Meanwhile, 70% of the high-speed rail track has been supplied by the Pangang Group, a large steel maker in southwest China's Sichuan province. Steel is an integral part of railway tracks, and the manufacturing of rails for high-speed railways requires even higher standards for smoothness and various sections. In the Pangang Group, the honor of fulfilling such a significant task is shouldered by the company's chief engineer, Tao Gongming, who's dedicated his 20-year career to the designing and manufacturing of steel rails.
高速铁路钢轨
Once fixed in place as high-speed railway tracks, the steel rails are welded seamlessly together as if they were two parallel rails extending out infinitely, connecting the stations along the way. Passengers can stand a coin steadily on the table inside the train, even when it's traveling at 300 kilometers per hour. And my duty is to enhance the quality of the steel rail and make the coins stand longer.
Born in 1970 and raised in Sichuan province, Tao Gongming majored in metalworking after entering university. He shared that he was already interested in steel rail design before he graduated.
I was pretty much fearless when I was young. Back then, I wrote a letter to the general manager of Pangang, asking if the factory was good, because I wanted to work there. And in his reply, the general manager told me to come to visit them and see for my own eyes if the work here would interest me. And eventually, I came to work at Pangang in 1992.
Tao Gongming believes that he joined just at the right time. In the late 1990s, the domestically made turnout tracks for railway projects gradually became incompatible with speeded-up train operations. The steel rails, therefore, were mainly imported from abroad at high prices, which triggered manufacturers like Pangang to gather up their engineers and workers to try to find a way out. Focusing his work mainly on the researching and developing of steel rails, therefore, Tao Gongming was also among the first group of Chinese engineers who started to design the earliest domestically produced high-speed railway tracks.
Turnout rails, particularly high-speed turnout rails, differ from standard steel rails in that they are significantly asymmetric on both the top and bottom, as well as the left and right sides. We had never attempted to manufacture them before, and every time we tested them and failed, I had to alter the whole pattern and try again. In some ways, rolling steel rails is like rolling pasta out of a dough, and in this case, my steel billet is the dough. But each test and tweak would come at a great expense.
During the early stages of research and development, the rolling of high-speed turnout rails failed frequently, resulting in losses surpassing 500,000 yuan, roughly over $72,000 each failure.
So I had always wished for software that could simulate the rail rolling process on a computer, that could virtually optimize the parameters on my whole pattern designs. Later, I learned about the finite element analysis software that could help with our problem.
Finite element analysis, or FEA, is a simulation and 3D design software that optimizes a product's design, detects potential defects, and even offers remedies to decrease trial and test time. And all of the aforementioned simulated results might be obtained simply by feeding the software with on-site manufacturing parameters. Realizing how the technology could maybe reduce testing time costs in the steel rolling process, Tao Gongming worked assiduously, giving his best try at learning how to utilize the software. It was, however, not a simple chore for him. Back in the 1990s, FEA was mostly employed in the aerospace industry and was not widely used across the country. Holding the full English software handbook in his hand, therefore, Tao Gongming had to literally start learning from the ground up.
Mr. Tao studied Russian back in university and only a little English, so he really had to begin from the basics and read the text by continuously checking the dictionary.
This is Guo Hua, the Deputy General Manager of the Pangang Group.
He mastered the use of the software's English interface as well as the entire simulation process through extensive self-study. Simultaneously, he incorporated more practical components into the simulation, such as temperature changes, friction, and so on. We thought this would significantly improve our product's overall development efficiency.
That was a time when the company was tasked with producing its own batch of high-quality turnout rails. To complete such a task was fraught with difficulties, and Tao Gongming, though just a young engineer back then, took up the challenge and began putting his knowledge of the FEA software into practical use. He carried on sharing that it was a memorable time filled with innovative ideas and breakthroughs.
We were expected to complete the production within 1 month. Under those circumstances, the usual design process would fall behind the schedule. So we analyzed the whole patterns of previous turnout rail products and combined them with those that I newly designed. The FEA program was quite helpful during this process.
Following multiple simulations and readjustments, Tao Gongming and the team eventually produced the steel rail in one successful roll and completed the manufacturing work 11 days ahead of schedule. According to him, such an achievement also marked the significant fact that China could finally develop and produce turnout rail tracks independently.
All of the engineers and technicians in the team were so excited by our accomplishment. But I was young at the time, and I didn't want to appear overly proud of myself in front of everyone, so I kept a low profile.
With a timid smile, it's obvious that the recollection and joy of that moment are still vivid in his thoughts.
But after I got home, I couldn't contain my joy anymore and shared it with everyone in my family. I told them that we achieved what we called a huge success on that day.
Having independently designed and produced their first turnout rail product, Tao Gongming and his colleagues were able to be more explicit about their future research direction, which was to continue enhancing the quality of the steel rail they created. At the turn of the century, the factory shifted their goal from producing turnout rails and common rail tracks to designing and manufacturing high-speed rails. In addition, as railway speeds in China increased, so did the demand for high-quality steel rails. Tao Gongming and his team quickly began a new round of study and were inevitably greeted with unexpected challenges along the way. The production process normally starts with the disposing of the billet steel, where measures are taken to regulate the residual element and gas content and ensure the purity of the steel. The steel billet would then go through several further processes such as rolling, heating, cooling, and straightening before being transformed into a segment of steel rail. According to Sun Bin, a fellow engineer in the factory that worked side by side with Tao during that time, Tao Gongming would always get down to the factory floor to observe each of the steps in person. Whether it was to improve surface smoothness or to prevent iron oxides from developing on the steel when rolling, they would always see Tao Gongming there, inspecting, as though no imperfections could ever escape his eyes.
I once saw him on the production line. Our containers were over 800 degrees Celsius at the time, and I spotted him standing there, monitoring and keeping a record of the freshly rolled rails. He was all sweaty and his face turning so red from the scorching heat, but he still managed to stay there for nearly an hour to finish the job.
Seeing the strict quality control performed by Tao Gongming, many other engineers in the factory started to follow in his footsteps and began improving the innovation process. After a few years, they were able to replace the old 25-meter-long rolling mill in the factory to one that was 100 meters long, which greatly improved the production efficiency. However, as productivity increased, new issues started to crop up. The team quickly realized that the longer each rail was, the more likely it was to experience pressure fluctuation from one end to the other.
When the rails are installed as train tracks, the railway department grinds the rail with a grinder. Even so, pressure fluctuations in the steel itself cannot always be totally prevented. When a train is traveling at 300 kilometers per hour, it might receive an alarm owing to pressure fluctuations in the rail, causing the train to halt automatically.
If the grinder can solve the issue from the outside, what if there was a method to detect the fluctuations from inside the rail? According to Tao Gongming, the homogeneity of the steel during production could be the key to tackling this issue.
During the production process, different degrees of homogeneity in the steel produces varied sounds. The sound will be quite smooth if the rail is flat and straight. However, if there are fluctuations, you might be able to hear them with your own ears.
Following up on his idea, Tao Gongming began in the most basic way. Once again, he came to the production line, listening right next to the rolling mill while jotting down notes on the sounds he heard, as well as the on-site parameters when the sound changed in preparation for future readjustments. It was a technical difficulty for railway producers all around the world at the time to ensure that the homogeneity of the 100-meter-long rails they made was consistent from one end to the other. But after more than a year of on-site data collection and small-scale testing, Tao Gongming's team managed to put together a computerized system that can monitor the pressure fluctuations in the rail and make prompt adjustments to the rolling mill's parameters to remedy the problem. To those of us who are unfamiliar with the science and technology used in rail manufacturing, outcomes like this might sound plain and simple when first heard. But behind each testing trial and adjustments made are meticulous calculations, extensive observations, and the unwavering efforts of the entire team. According to many colleagues who know him, Tao Gongming, the team's backbone, is the one who dares to speculate and assume while remaining cautious as he seeks for proof to establish that his assumptions are correct.
I have always believed that the best teacher is one's own curiosity, for it will push us to keep doing what we are doing and staying on track till we reach our goals.
Indeed, Tao Gongming has often demonstrated that he does not easily abandon his pursuit of excellence. While making high-quality steel rails, it has gradually become a habit for him to constantly look for solutions to new problems as they arise. Once the efficiency and quality detection was secured for the rail production, what Tao and his team wanted to conquer next is the challenge of reducing costs. Around a decade ago, the factory's manufacturing line was equipped with a straightener for the bending and straightening of rail tracks. Usually, the straightening step would follow once the rolling and bending process was completed, since the steel would get cooler and thus easier to process afterwards. As a result of such temperature variations, the metal would naturally curve after buckling in the heat, necessitating the use of straighteners to bring it back into line. However, the multi-roll straightener they possessed at the time could only cover the bulk of the central section of the steel, leaving the two ends as blind areas where the roller could not reach evenly and hence failed to straighten. Because of this, approximately 1.6 meters on both ends of each steel rail they produced had to be cut off and regarded as waste during the process. Though not a new problem faced by many train track producers throughout the world, Tao Gongming was determined to find a solution.
Such fine materials transformed all the way from steel billets to rails, with so many processing steps throughout, and a high cost of several thousand yuan per ton. I felt it was extremely wasteful to have to chop any part of it off due to mechanical issues. So far, we've been attempting to determine how to maintain a consistent straightening force from one end of the rail to the other, so that the rail quality of the two ends could be as good as that of the center.
After repeated investigation and brainstorming with the team, Tao Gongming presented a bold idea to add a second set of straightening devices at both ends of the straightener. One of these devices would begin by stretching out the head of the rail as it was rolled into the straightener, leaving the other one to wrap up the straightening operation and stretch out the rail base as it rolled out from the other side. No sooner said than done. The team immediately put together the devices as per Tao's idea and organized the trial testing by inserting steel rails in.
We did a thorough check on the sample rails yesterday,
says the quality inspector.
and its quality and straightness are both good. As good as that in the center.
He continued as he moved on to another rail section.
Okay, this one is all good too.
According to the calculations of the World Bank, a key factor that's keeping down the rail production cost in China is the standardization of designs and procedures. The construction cost of the Chinese high-speed rail network at an average of $17 to $21 million per average is about 2/3 of the cost in other countries. Behind these data are the countless efforts of people like Tao Gongming who have dedicated their career to improving the high-speed rail's quality as well as cost efficiency. With their devotedness, the Penggang Group has exported its rails to more than 30 countries and regions across the world in the past few years, including the United States, Canada, Brazil, Australia, New Zealand, Mexico, and Vietnam. Tao Gongming, meanwhile, has remained at the front line of the manufacturing team, continuing to inspire himself and his colleagues with innovative ideas. In 2015, he was given the honorary title of National Model Worker, along with 2,063 other candidates. The title is given by the Chinese government, and candidates are elected only once every 5 years. As a national honorary title, it is given to the outstanding representatives of the country's working class and the broad masses of the working people.
I'd like to think of steel rail production as an endless operation. To my mind, as long as the production line is working, it will then continuously produce rails that will connect more places into one long line. The rail would have no beginning nor end, and since the production line is always running, we could supply as many kilometers of fine quality rails as required. I'd like to achieve that goal one day, and in the meantime, maintain the good quality away from pressure fluctuations or blind areas that cannot be straightened. It is our aim to provide the best steel rails in the world.
With that, we conclude this episode of Footprints. Thanks for listening. I'm Yu Shan. If you're interested in hearing more about the lives of ordinary people in China, follow us on Apple Podcast. Just key in footprints and you can find more stories anytime, anywhere. We'll see you next time. Bye for now.